Encoding the user credentials that we store within our databases is definitely a best practice, but there are still some vulnerabilities that occur when we encode using something like a common hashing algorithm like SHA-256. For example, if we were to navigate to any website that allows us to hash out a particular string, we can just put in, let's say, password as the text, and it's going to return us the hash values of many one-way hashing algorithms. And there you see there is SHA-256. So if I were to take this value and we return to our application, and now we compare this to the hashed password within our database table, we get the same values in our database that we just received. What attackers normally do is they will build out basically dictionaries of common passwords, and then they can just run and check against any databases they have compromised that contain user passwords for these common hashes. So there we see it's an exact match. So it's not really going to stop an attacker just having our passwords encoded. This is where a technique known as salting comes into place. And the basics behind salting, you add some unique data to your hash. So maybe I'll add like an 8-character random number to the beginning of my password, and then I will hash that using SHA-256. And when we do the hashing, we make that 8-digit string unique for each individual user. This means if an attacker were to get all of our encoded passwords within the database, they would need to decode each individual value that has been salted, because it's not like the same salt has been used across every password. So in order to find the matches, they would need to treat each individual salted password as its own problem. And that's going to really expand the amount of time it takes them to basically find out what the clear text password is. So all we need to do is create a bean, and we're going to call this bean password encoder. And then for the type of this bean, we're going to use a standard password encoder. So I'll just declare that bean, and then I'm going to grab the ID of that bean, and we will change our password encoder tag to a reference to our password encoder bean. So at this point, Spring Security will be using a standard password encoder, which does salt the passwords that it is provided. And we can see that in action if we visit our password encoder class. And all we're simply going to do is change our SHA password encoder to a standard password encoder. So I'll just modify the constructor, and we don't need to provide any arguments to this constructor. And then instead of invoking the encode password method, we simply invoke the encode method, and that is going to salt and hash our password. And we also don't need to provide that second argument. Now, if we were to bring up our console and we ran our password encoder on our password, there you see we get a different hashed value, and that's because there was salt added to that value that we are encoding. And if we run it again, you'll notice we get a different encoded value, and once again we get a different hashed value. So all we need to do is take that value, copy it, and then we can head to our init.sql file, and we can replace that with our encoded password. At this point, we now have the salted, hashed password within our database. So we're going to restart our application, and we'll simply attempt to log in with our end user here that we have provided that password for. So now I'm just going to navigate to the application. I'm going to log out end user, and then we'll sign them back in. And there we see we were able to use a salted and hashed password with our standard password encoder in order to add some additional protection for our users' credentials that we are storing. So this is definitely a best practice, even more so than just hashing your password values. When we use those standard hashes, there are what's referred to as rainbow tables out there, and they're basically dictionary tables for these hashes that an attacker can just bounce a particular hash against until they wind up with your clear text password. That becomes much more difficult and much more time consuming when we use a salted hashed password.